In this problem, we are sketching the graph of a function that is logarithmic. And we've got a table of characteristics down here, and we've also got some information about limits. So let's start reading through the limits and see if we can make sense of what this is going to look like. It says the domain of f is the union of two subdomains there from negative infinity to negative 2, and then it skips a couple of spaces and then starts up again from 0 to infinity. So we're going to have a space in the middle where the function's not defined at all. And it is continuous on both those subdomains. Okay. So the limit as x approaches negative infinity, so way over on the left side of the graph, it's 5 times the natural log of 3. Okay, wherever that is, we'll have to graph that. What this is going to be is a horizontal asymptote. So when x gets further and further to the left, it's approaching that value 5 times the natural log of 3. So horizontal asymptote there. And then let's see, as x approaches negative 2 from the left, the function goes down to negative infinity. So that's a vertical asymptote there. And then as x approaches 0 from the right, it goes up to positive infinity. So that's a vertical asymptote there as well. And then on the other side here, as x approaches infinity, we're also having a horizontal asymptote of 5 times the natural log of 3. And then according to our chart, we've got a point here, negative 3, 0, and then we've just got all these undefined values, negative 2, 0, and everything between negative 2 and 0. So what I did with this is I went ahead and plotted that point, and then I plotted the vertical asymptotes where it's undefined at x equals negative 2 and x equals 0, and then I put in the horizontal asymptote at 5 times the natural log of 3. So this line here is 5 times the natural log of 3, here's negative 2, here's 0. So what remains now after you've done that preliminary work, is to use this information about the first derivative and the second derivative to know what kind of shapes of curves to put in there. This says that from negative infinity to negative 3, it's a negative slope and it's concave down. So negative slope, concave down, and that's up to that point, okay? And then, well, so it continues to have that same slope and concavity at the point that we've got graphed there and afterwards. So that's going to be kind of a smooth continuation of that thing. So nothing really to worry about there. We're just going to grab the same thing and continue it on down. And you can see it does approach negative infinity there at x equals negative 2. Okay, we've got nothing to graph in the middle. We've got something to graph out on the other side. Where exactly it's going to be? Well, we can figure that out here. It says between 0 and infinity, we've got something that has a downward slope but concave up. I think the only place that can fit downward slope, concave up is going to look like this. You couldn't really fit that in the bottom in any meaningful way to interact with the asymptotes. It's only going to fit in up here where it can be with both the asymptotes in a way that makes sense. So that goes there. And I think we've done it. So let's go ahead and check this and see. Yep, very good. So that's some work with sketching the graph of a function that has logarithms.